ready to move on to Newton's second law. And Newton's second law is actually so long that I'm going to paraphrase it, but only very slightly. So Newton's second law states that acceleration is directly proportional to net force and inversely proportional to mass, and that acceleration is in the same direction as force. So let's break that up a little bit so we can understand it better. When we say something directly proportional to something else, we mean that acceleration, represented by A, equals some constant times force. And when we say that it's inversely proportional to mass, then we say that acceleration is some constant times 1 over mass. That'd be the inverse of mass. So since force and 1 over mass are both constants, we can substitute them in for each other to get force over mass. So we can say acceleration equals force over mass, or actually in the standard form, we say force equals mass times acceleration. And this is the famous form of Newton's second law. F equals ma. And there's a variety of different notations, but it's just very important to remember that in all of them, these two terms, force and acceleration, are vectors, and they always point in the same direction. Now you can express this equation however you want. You can say F equals ma. You can divide through by acceleration and say force over acceleration equals mass. You can divide through by mass like we did before and get force over mass equals acceleration. They're all the same equation. And actually, a lot of times that's very useful if you're looking for some quantity or another. For instance, you know that you have a force of 20 newtons and a mass of 2 kilograms, and you want to find out the acceleration. You'd go to the equation where force and mass are on one side and acceleration is on the other, and then you'd just get 20 newtons over 2 kilograms. And as we mentioned previously, 1 newton equals 1 kilogram meter per second squared. So we end up with 20 kilograms meters per second squared over 2 kilograms. And then the kilograms cancel, just like we did in canceling of units. And as a result, we're left with 10 meters per second squared. And meters per second squared is the units for acceleration. So that makes sense. We've calculated the acceleration that a 20 newtons of force would do on a 2 kilogram object. And the interesting thing here is 20 meters per second squared is about the same acceleration as gravity. So we would know that 20 newtons is actually about how much force gravity exerts on a 2 kilogram object, or about how much a 2 kilogram object weighs. Now you can do the same thing for any of the other formulations of Newton's laws. In F equals ma form, if you have m and a, you can find F. If you're in acceleration equals mass over force form like we were before, you can find acceleration. So that should be force over mass. Or, if you're in mass as force over acceleration, you can calculate the mass. So using all of these different things, you can use F equals ma, Newton's second law, to calculate a variety of constants, and it really works very well in solving a lot of physics problems. Now, F equals ma is responsible for one of the most interesting physics phenomena, which is the fact that everything falls at the same speed. Whether you drop a small tennis ball or a gigantic ton of bricks, in every one of these cases, it's going to fall at the same speed. Now, it might not seem that way. For instance, a paper falls slower than a bowling ball, but that's actually for a different reason. That's because of air resistance. In the case of the tennis ball and the ton of bricks, they fall at the same speed. Now, you might wonder why this is. We've already discussed the concept that because the ton of bricks is a higher mass, there's a higher force. So the downward force on the ton of bricks is much higher than the tennis ball. And let's say the ton of bricks is 100 times heavier. Then we can say that the force on the ton of bricks is 100 times the force on the tennis ball. So that leads to the question of, why would they fall at the same speed? Why would they accelerate the same amount? It doesn't make a lot of sense. And the reason for this is when we look at it, because of F equals ma, or more specifically because acceleration is force over mass. We know that the tennis ball only has 1 times the force acting on it, but it also only has 1 times the mass. Whereas the ton of bricks has 100 times the force acting on it, and 100 times the mass. It actually has the same acceleration. And we did this without units. We could give the specific units for the weight and mass of the tennis balls and the acceleration they experience, but that's not really necessary. The point is because it scales the same. because twice as much mass gives you twice as much gravitational force, but also makes it twice as hard to accelerate. That everything falls at the same speed. And that was another one of the experiments that overturned a lot of the Greek physics and actually ushered in kind of the new age of physics. So congratulations, you now understand Newton's second law, and now you're ready to move on to his third law.